Right gang, welcome to another Autodesk Inventor video. What we've got here is a bracket that's one of the bricklaying students asked us to manufacture so they could attach it to the wall and load it up with some of the tools that they're using. And what we're going to do in this video is we're going to run some tests on it to see, basically to see how strong it is, how much it moves, what sort of impact adding loads to it is going to have, with a view to see whether it's going to be big enough, strong enough, wide enough, etc, etc. So without further ado, what we're going to do is we're going to run through some testing. Now, first thing you've got to do here is open up your Autodesk Inventor software. This is for you guys that maybe not necessarily that familiar, and you find that in the Start menu. So you click on Start menu and then you've got your software just there. So if you click on that, okay, what will happen is this screen will open up. Now, what you actually want to do is you want to just close that down, and then you're going to go up to the Open tab, select Open, and then you go and find the file that you're going to run and test. And that may be a file that you've created, or if you've downloaded this file from Canvas and you've got it saved on your login, then you just go and find it. So I've actually clicked on that one and I've opened up. Okay, so I've got my file open. Now, what I'm going to do now is I'm going to come up to the ribbon or the toolbar, as some of you might be a bit more familiar with it, and we're going to look at this Environments tab. So by analysing it, we're going to do what's called stress analysis, or finite element analysis is this kind of generic name for this. Autodesk Inventor calls it stress analysis, although it doesn't just measure stress. So what we're going to do, we're going to select that tab. Now, if you're not necessarily that familiar with this software, when you choose a command, such as the stress analysis one, it brings up a new set of tools for you to use. And what we're going to do here is we're going to create a study. Alright, now you've got different types of studies. As I mentioned earlier, this is going to get attached to a wall through these holes, and then it's going to get loaded up. So in effect, this product should remain static, so that's why we've got the static analysis tab selected, and we're going to select OK on that one. Now, just at this point, you could rename that if you wanted, but we'll just call it number 1. OK. And what that does, by setting up that analysis, it makes these commands live. All right. Now, the command that we're going to start off with is this fix one. Now we're doing some basic testing, so there's kind of limited stuff that we actually need to use along the top. But again, the more sort of proficient you get, the more and more things you'll be able to analyse with it. But we're just going to select that Fix tab. I'm going to zoom in, because it's much easier if you zoom in. I'm going to fix this on that edge, because that's where this fastener that's going to put this on the wall is going to connect. I'm going to do the same there as well. And then if I zoom out, I can go down and pick that bottom one up. Now you might be asking why I've only got 3 holes in this and not 4. We're only missing at the moment, so if we wanted to add an extra hole on, we could do that a bit later. Okay, but we're going to apply that. Now when you apply these, it keeps that dialog box open, so you could actually go around and fix some other things on it, but we're just going to leave that as it is for now, so to select cancel. Okay, next thing we're going to do, because that's actually fixed, it's fixed on those holes. So next thing we're going to do is we're going to apply a load. Now, as I mentioned earlier, it gets attached to the wall. Someone sits on top of it, so that will be represented by this force tab. So I hover over where I want that force to go, and then I select that, and you'll see that little arrow. So that's telling us what direction the force is going to go. If I want to move it in the opposite way, which I don't in this case, but I select the direction tab. Now, when we did this with the students who actually went through the manufacturing process, we calculated that the load that was going to be applied was about 10 kilograms, or the mass was about 10 kilograms, and the load ends up 98.1, but we're just going to call it 100 for this. Okay, I'm going to OK that this time, or if I select apply, but I'm going to OK that, and that will close that dialog box down for me. Last little bit before I run the test, I'm just going to create that mesh view. Now, again, this mesh stuff, it's a little bit more advanced than the point we're at this stage, but it just allows you to focus in on specific elements of the product with a bit more effect. And you can change the size of the mesh, etc. When we get a bit more advanced. Now at the moment we know that it's fixed against through those holes. We've applied the load, so all we need to do now is to run the simulation and we'll get some results. Alright, it takes a few seconds just to run through. The more and more complicated your jobs get, the longer that process takes. Because this is quite a simple project, it runs through pretty similar. And if we flip that around, we can see it's got a bit of a twist on, which again you'd expect because there's something going on with this bit of the material. So I'll let you have a little think of that, and we can zoom in there and we can actually see where the most amount of stress is. Yeah, and that red section there that we can see is what's actually represented by that value up there. So I'll come back to my home menu. Okay, so let's just have a little look at the results. So up here I've got a maximum stress value of 590.1, and the units for that are megapascals. Okay, now what I want you to do is I want you to actually have a play around with this and run some tests so that we can analyse some different materials. So what I'm going to have to do so that I can analyse this is I need to log that number somewhere, and to do that I've simply just set up a Word document. It's got a table on it with some test results. I've named the material, I've actually put a little image in there of the test that's happened, and I'm going to log the value for the stress in there, and 590.1, and that's megapascals. And that's 590.1 times 10 to the 6 for you guys that maybe forgot your engineering notation. I'm going to go back to my software now, and I'm going to get a little bit more information while I'm in here, and I'm going to go for this displacement and the safety factor. The safety factor is the same as factor of safety, which you might be familiar with from your science, but displacement, simply get those results by double clicking on it. Okay, so it changes these units up the top, and you can actually see it's changed the image there as well. So by displacement, what they actually mean is how much this thing has moved. Right, so that was its original starting point. Run that white line there, and we've added the load, and it's actually moved. Okay, now that's just a visual representation. It's this information over here that's most important, that 3.14. Okay, I'm gonna have a look, make sure I've got my millimeters, that's the correct unit, and I'm going to go 3.14. I'm going to go to my Word document and do 3.14 millimeters. Alright, so you notice here I've got a few other rows set up so I can put some other materials in. So I'm going to actually get you to run some tests on some different materials, but what we'll do is I'll show you how to copy your simulation in the next video. Okay, so this is just sort of showing you how to set up the first one. And the last bit of information I'm going to go and get is the safety factor. Let's do that by going safety factor, factor of safety, if that's the way you want to do it. Now I've got two bits of data I want to collect here. I've got 15, and you might remember from your science sessions there's no units for safety factor. So we've got 15 as the max and 0.35 as the minimum. So I'm going to go there, 15 max, and let's say 0.35. Yeah, let's go back and double check that. Yeah, there we go. Okay, now you might benefit from having a pen and a bit of paper next to you, and you can write that data down. You know, if you jump in between screens and bits of software and stuff, it's quite easy to forget a decimal or put the wrong value in. Okay, so you're going to save that information. Don't need to tell you how to do that in a Word document, do I? You're going to save that, and then we're going to have a little think about, in the next video, we're going to actually look at copying the simulation and getting some other results so that we can compare and contrast some different materials. Okay, so feel free to pause the video, if you want to have a little go at that yourself. I'd highly recommend it, because for those guys that are going to be working on things like occupational specialism and player-set project over the next couple of years, then this is the kind of evidence that really looks good when you get it into your reports. Okay, so once again, thanks for listening, and I will see you in the next one.